This is the review for the Algebra EOC 1A. On problem number 1 here, you can see it at the very top of the line. It says that we have to figure out what the first incorrect step is above. So I'm going to go ahead and go over this one by one. So what you need to do is look at the first line and compare it to the second line and see if you can tell what has changed. And the obvious thing should be the parentheses, and we know that that would be the distributive property. So we have to check to make sure it was done correctly. So to do distributive property, we'd multiply -4 times 2m, we'd get -8m, and also -4 times 5, and get -20. The right side is the same, so I'll get it in blue here. So step 1 is perfectly fine. So then, looking at step 1 and 2, I noticed these are different, and also the 3m is different, so they must have subtracted 3m from both sides. So 3m minus 3m goes away. -8m minus 3m does give me -11m, so that one's fine as well. Next one, thing that jumps out at me is this is missing from down here, and this number is different. So they would add 20 to both sides to make it go away there, and adding 20, I should get a 55, but if you notice right there, that's not 55. So that is my mistake. So it's found in step 3. Number 2 has a student that has received 3 scores so far. I'm going to zoom in just a little bit more. So you can see the scores are 62, 68, and 75. I'm going to go ahead and highlight those on 3 different tests, and the goal is to get an average of 70, or actually at least 70. So let's go at least, and well, that's where we know. So we have to figure out what we need to get on the next test to bring that average to 70, or we don't even really know what the average is right now. So averages, if you remember, is when we take the sum of the things we're looking at. In this case, we have 3 scores so far. You would add them together and divide by the number of items. So that could tell you the average now, but we want the average with one more thing, one more test. So that would be dividing by 4. So we need to set this up. So first off, we would have 62 and 68 for the next test, 75 for the next test, but we don't know the next one, so we're going to go ahead and call it an x. Then we're going to divide by the number of tests, which will be 4, and at least means we're okay if it's more, but we're not okay if it's less. So it can be more, but it could also be exactly 70. We're good with that. So we want this average to be at least 70. All right, I need to solve for x. So first off, I want to get rid of this 4 here. So I'm going to do a couple things at once here to save some time. I am going to go ahead and multiply both sides by 4. That'll take care of that. And in the same line, I'm going to go ahead and add these 3 numbers together. So on the right side here, 4 times 7 is 28. So I've got 280. And on the other side here, I need to go ahead and add these 3 numbers together. So I have 68 and 72 and 75. So that's giving me 205 plus x. Well, I still need to get x by itself, so I'm going to go ahead and subtract 205 from both sides. That will cancel out there, and minus 205 here means I'm going to get my answer. So we need to get a 75 or more, but the way it asked was, what do you have to get at least? So you have to at least get a 75. Now, I've had other students say that they've done this slightly differently, and that's fine if you want to do it a different way. I've had some students even do something cool, like they said, we had a 62, a 68, and a 75 so far, and 62, our goal is 70, so this is 8 less than our goal, this is 2 less than our goal, this is 5 more than our goal, and we have to have, one more thing here. So what would this have to be in order to cancel all this out so we're at our goal? Well, -8 and -2 is -10. Plus 5 still means we're at -5, so we would have to get plus 5 again, which once again leads us to 75 is what we need. So that's a slightly different way to do it. Number 3 says to solve for y. So the first thing we have to do, though, is get the term that contains the y all by itself. So I'm going to go ahead and subtract 4x from both sides. And I'm putting this slightly off to the side because they are not like terms, so I don't want to risk combining them. These are like terms, and they'll cancel out. So 3y is now going to equal 9 minus 4x. You could also write -4x plus 9 if you prefer. So now I have the term with the y by itself, but I don't have the y by itself. So I'm going to go ahead and divide both sides by 3. You could also write one big line right here and a 3 if you prefer. So this will cancel out right there, giving me y is equal to 3 minus 4/3 x. Just as a little side note here, there's going to be a problem later, I think, in this one where this is going to be important. So you can also write that as -4/3 x plus 3. We're just changing the order there. So this is one or the other. They equal the same thing. All right, number 4. It's an absolute value problem, but we first want to get the absolute value term by itself. So in order to do that, I have to do something with the -10 and then the 2 out front. So first off, I'm going to go ahead and I think I'm going to write this off to the side just because I think I'm going to need some extra room. So I'm going to go ahead and move this over here, just copy it down as is. All right, then the opposite of subtracting 10 is adding 10. So I will go ahead and do that. It'll cancel out the 10s. And now I have 2 times the absolute value of 3x plus 9 is equal to 2 plus 10, which is 12. Now the temptation for a lot of students right now is going to be to distribute. Please do not do that. Instead, what I want you to do is divide both sides by 2. That will cancel that out right there and get the absolute value term all by itself, and 12 divided by 2 is 6. And here's why I wanted to write that to the left there. I knew I was going to run out of room. All right, so remember what absolute value is. It's the distance from 0 on a number line. So thing with this one is it's saying that this amount is 6 units from 0. But that could mean it's at 6 on the number line, but it could also mean it's at -6 on the number line. So I'm going to go ahead and take those both into account. And I do that by doing this. It might be 3x plus 9 is equal to 6, or it could be 3x plus 9 is equal to -6. Notice that the only thing that's different is on the right side of the equal sign. The left side stays the same. So I have to solve each one. So -9, -9. That'll give me 3x. This cancels. 6 minus 9 is -3. Divide both sides by 3 to cancel that out. And x is -1. But now I do have to do the other side. So -9 minus 9. That's going to give me 3x is equal to -6 minus 9 is -15. And now to get x by itself, divide by 3, and you'll get x is equal to -5. Okay, I'm going to go ahead and circle that. There's a lot going on here. So notice that they're not opposites of each other. Some students seem to think if one answer is -1, the other answer must be +1. So that's not the case. It's also sometimes true that they're both negative or they're both positive. So you just have to make sure you do all the steps and don't make assumptions at the end because you might get that wrong. Now, the last one I'll do on this recording is number 5, and it says, what is the solution to this inequality? So once again, we have to solve for x, but first I'm going to go ahead and get the term that contains the x by itself. So the opposite of adding is subtracting. So I will go ahead and do that, and that will give me negative 2x is greater than or equal to 4. And now I'm going to go ahead and get x by itself. Right now it's negative 2 times x, so I'm going to divide by negative 2. So that cancels, giving me x, and over here I'm going to have negative 2, but here's something else. There's this little rule that said if we divide or multiply by a negative number when we have an inequality, that middle symbol is going to flip. So instead of greater than or equal to, it's less than or equal to. So that is something you might want to take note of. I'm going to just add some highlight right there of that. And off to the side, if you want to, you can always add something like when multiplying or dividing by negative, flip the inequality.